Okay, so let's continue here. A study is being done on the effectiveness of the flu vaccine. The data is shown in the table below. Okay, so if we're doing the effectiveness of the flu vaccine, we're trying to look into the future to see if it works or not, right? Well, if we're trying to decide that, what are we going to look at? Well, it's going to be a cohort study, because cohort is relative risk, right? And we already know it's retro or prospective, so future or the past. What would be, if it was an odds ratio, what is that? Odds ratio is a odds ratio. It's a case control study. It's different. Cohort study is what? Relative risk, right? Similar. OO, RR. Odds ratio is OA, OA. Okay? I don't know, just something to keep in mind. I don't even know if it's going to help in this question, but just something important. Okay, so we know it's a cohort study. We're using relative risk. Relative risk was 1 over 2 numbers, right? Okay. But here we go. Based on the table, how many patients need to receive the flu vaccine for one patient to benefit from it? Okay, so what is this even asking us? All right. One patient to benefit from it. Well, this is probably numbers needed to treat. If you're benefiting from something and they want to know how many people you need to treat so someone could benefit from it, that's going to be number needed to treat. Similar to number needed to harm, instead of harming someone, you're treating someone. Same exact formulas, same exact thing, used in the same way. Okay, so if you know that, you're like, okay, let me find N and T. Slow down. How are we going to get N and T? Well, you need to calculate for AR or ARR. Oh boy, which one? Which one do we do? Well, basically the same formula. So, who cares? But if you really wanted to know, ARR goes with N and T. So these two go together, and then N and H goes with AR. But I don't know, it's something I'm not memorizing. I don't really care. I just want to get the answers right. Okay, so here we go. Let's make our table. Why was this so redundant? Because if they mess with us, then we are not going to be caught off guard. But here, we're lucky enough they didn't mess with us. On top, we have flu, which is reality. Okay, on the left, we have the test. Well, not the test, but vaccine or no vaccine. So we're going to do vax or no vax. Okay, positive, negative. We know positive, negative. Okay, so now let's plug in our numbers. Vaccine, flu, 2. Vaccine, no vaccine and flu, 15. No vaccine and no flu was 5. And then vaccine and no flu was 18. Okay, so just take these numbers, just plug them into the chart as they go, right? They just go like that. All right, they didn't really mess with us, thankfully. So we have our chart. Boom. Now what are we trying to find? Well, we're trying to find ARR. Because we need to use him to put into our equation for N and T. N and T was 1 over ARR. How the hell do we do this? Well, we should know it's basically attributable relative risk. So we know how to find relative risk, right? So instead of finding the entire relative risk, we're just trying to find an attributable version of it. What does this even mean? So we're just going to take these numbers and we're going to subtract them from these numbers. Okay, let's do it. So we're going to do 2 over 2 plus 18. Instead of dividing it, we're not going to divide it. So we're not trying to find that right now. We're going to subtract it. Okay, over 15. 15 plus 5. So let me reduce it real quick. 2 over 20 minus 15 over 20. Okay, well, I'm not doing this on my own. I'm going to have the calculator do it for me. 2 over 20 is 0.1 minus 15 over 20. 0.75, right? Okay, well, the answer comes out to negative 0.65, right? Well, we know that we can't really use negatives in this situation. So whenever I see this, I'm like, all right, something went wrong. I'm just going to take the positive version of it. I probably messed up, which I did in this situation. How did I mess up? Okay, this is how I messed up. Let's do it in blue. What is ARR? It's going to be control minus what? Treatment. What did I do? I did treatment minus control. Damn. Okay, well, good thing I caught it because I saw a negative number. So, not too bad. Whatever. Happens. Life sucks sometimes. Just going to restart. Not too shabby. Whatever. Okay, so you do control, right? Because control is not being vaccinated. So, you're going to do 15 over 15 plus 5 minus treatment, vaccinated, 2 over 2 plus 18. Now let's reduce that to 15 over 20 minus 2 over 20. Have the calculator do it for me again. 15 over 20 is what? It's 0.75 minus what? 2 over 20. It's 0.1. Okay. Still 0.65. So I know it looked really bad that it's a negative, right? But in the grand scheme of things, it doesn't matter. Just if you have this equation and you put control treatment or you do treatment control, it's just normal algebra. Make sure to put it in brackets like this. So I forgot what this is even called in math, but when you do that, you know everything's got to be positive. So if you do that, no matter if you get a negative or a positive, you know 0.65 is going to be your ARR. Okay. So now, what are we going to do? We're going to do NNT equals 1 over ARR, which is 0.65. We're going to put in the calculator, 1 over 0.65. What are we going to get? We're going to get 1.538. Okay, so now we know that we need 1.583 patients, right? Need to receive the flu vaccine so one patient can benefit from it. So E is going to be our answer. All right. Moving on. An investigator is studying the efficacy of a new medication that is similar to denosumab. No idea what that is. It's irrelevant. You can cross them out. In preventing hip fractures in patients above 60 years of age with risk factors for osteoporosis, but no confirmed diagnosis. Participating patients were randomized to either pharmacological therapy with a new medication or placebo. The results show blah. Okay. All I care about right now, boom. New medication or placebo. Okay, so we know we're going to do a drug versus a non-drug. So what is that going to be? We're going to have a control group and a treatment group. Okay. Let's keep going. Based on the information, which of the following represents a relative risk? Oh, we're in good shape here. We know relative risk really well. Okay, so let's draw our little box. They kept it nice for us this time. Reality was the same. Hip fracture, right? So we have our hip fracture. We have a positive. We have a negative. Okay. Now our therapy, our test was therapy. So our treatment. So we have our treatment. Or non-treatment, which is what? Our placebo. Okay, so we're going to just plug in the numbers because they kept it the same for us. And then what are they asking us for? Okay, relative risk of hip fracture in the treatment group compared to the control group. All right, so we read left to right, it goes top to bottom. So that means left is relative risk of hip fracture in treatment group. So left is the top compared to the control group. Control group is the bottom. What was relative risk? 1 over 1 plus another number. So 1 over 3 plus 97 over 10 plus 10 plus 190. All right, so we're going to have 1 over 100 over 10 over 200. You know I am not doing this. 1 over 100, we got 0.01. 10 over 200 is going to be what? 0.05. These numbers look really weird. Put in the calculator again. Okay. And we get 0.2. Okay, so if we come here, we're like, all right, good, we're good. We're in good shape. We come over here, we see 0.02. And we're like, whoa, buddy, what is good now? Well, if you see numbers in percents, don't panic. Just multiply it by 100. That's how you get out of decimals into percents. So 100 times 0.02 is 2%. So this is our answer. Not too bad. We're doing well. Here we go. A new controversial study in a medical journal found a higher incidence of myocardial infarction in individuals who drink red wine more than 5 times per week. A key data table for this study is shown below. So here's our table, whatever. If the data is correct, so hopefully the data is correct, how many people need to drink red wine more than 5 times per week to produce 1 additional case of myocardial infarction? Well, what are they asking? Okay. How many people need to drink red wine? So they want them to drink red wine. More than 5 times a week to get this. They want this to occur. All right, so, I guess they're looking for number needed to harm. They want to harm people. In reality, in the grand scheme of things, they don't want to harm people. They're just trying to find this number to see what happens so they know the amount that people drink, if it's going to harm someone or not. They're not purposely trying to harm someone. But it's the number needed to harm. Okay, so we're going to start it off. We know NNH is the same as NNT, right? Number needed to tree. We know for these guys, we need to use what? Well, we need to use AR or ARR, same formula. If you really want to know, ARR goes with NNT and AR goes with NNH, but it's the same thing. So let's find our AR. Okay, let's make our table. Okay, so let's see. We have reality. Did they keep it the same for us? They did. Okay, so we have an myocardial infarction, or you don't have one. So MI, we'll do that. And then we're going to do test is going to be our consumption. Well, what is consumption kind of like? Is it like treatment or controlled? Not really, but like you could think about it that, right? So you could be, what would be the control group? Well, it's going to be the people who drank wine more than 5 times a week. Okay, so that's going to be the control. And then if they didn't drink wine more than 5 times a week, that's going to be our okay, so we have our reality, right? They kept the graph the same for us. We have positive, negative, and now we're going to have our test. Okay, the test is going to be, well, there's nothing to really test for. They just gave us wine consumption, so we could do consumption, right? And now if we're like, wow, I do not know what to do, I'm bugging out, it's a test, I forget. Well, don't worry, it's fine. It's really not too important. We're going to always put things in these brackets, I said, right? Oh, that's what those are called, absolute value. We're always going to make it an absolute value. Okay, so if we have more than 5 times a week, we're going to do positive, right? That's how we're going to do it. Are we right? I don't know, but it's going to come out to the same answer. All right, and then if it's less than 5 times a week, we're going to put negative, whatever, and we're going to just keep the graph the same, how they gave it to us. So I'm just going to write 25K, 75K, K is 1,000, 20K, 80K, right? Just to fit in the box. Okay, and now, say I forget what I'm supposed to do. Doesn't matter, putting it in an absolute value bracket. So I'm going to make my absolute bracket value out here. What am I trying to search for? All right, I'm trying to find ARR, which was the absolute relative risk. And what are we going to do? We're going to do control minus treatment, right? Well, we could do that, or we could do treatment minus control. Doesn't matter, we're in this bracket. So I want to go top to bottom. That's how I like to do things, top to bottom. So we're going to go 25,000 over 25. We're going to do K plus 75K, right? And we're going to subtract that from what? The bottom one, 20K over 20 plus 80K, right? All right, so let's reduce it real quick. We're going to have 25K over 100K minus 20K over 100K. Okay, well, this math I know how to do because it's the same common denominator. So we could do 5,000 over 100,000. And we probably could reduce, but we have a calculator in the test. Let's just use it. Why not? 5,000 over 100,000. What do we get? We get 0.05. So our ARR is 0.05. Is this our answer? Let's go to it. Oh, that's a bad color. Do ARR equals 0.05. Well, we're looking for what? Number needed to harm. Okay. Number needed to harm is just 1 over ARR. So 1 over 0.05. Okay. 1 over 0.05. Go into the calculator. We get 20. So our answer is going to be 20. So if you just break it down like this, it's really not too bad. And who cares about if you know what you're doing or if you don't know what you're doing when it comes to these brackets? What if I did the bottom first? Okay. If I did 20K over 20 plus 80K minus 25K over 25K plus 75K, I would get 20 over 100 minus 25 over 100, right? But keep in mind the absolute value. And I would get negative 5,000 over 100,000. And this would give me what? Well, this would give me negative 0.05. But if we're in the absolute value bracket, we just know it's 0.05 and it's going to work. Don't get too stressed out. It's not too bad. Just break it down slowly. Okay, here we go. This is a long one. Why? They just love to do it. A cohort study. Boom, cohort. What are we doing? Cohort. OO. What does OO mean? Relative risk, right? What is relative risk? Future. Prospective. Easy enough. Okay. A cohort study was conducted to investigate the impact of post-traumatic stress disorder on asthma symptoms in a group of firefighters who worked at the California wildfires in December of 2017. Okay. And developed asthma in the aftermath. The study compared patients who had PTSD with those who did not have PTSD. All right, sure. In order to determine PTSD is associated with worse asthma control during a follow-up period of 24 months. All right. So we know it's the future. They already told us it's cohort, so the cohort is the future. Researchers found patients with PTSD had a greater number of hospitalizations. Why are they giving us all this stuff? After adjusting for medical comorbidities, psychiatric comorbidities other than PTSD, and socio-demographic variables, results are shown. Why did we get all that? Based on these results, what proportion of asthma hospitalizations in patients with PTSD could be attributed? So they really gave us all of that information, that whole entire paragraph, to ask that question. What are they even asking us for? They're asking us for our attributable relative risk, right? That's all we need to know. But what are they? They're not really. They're asking us for attributable relative risk %, so our ARP technically. So, okay. Well, what is ARP? Well, it's not too bad. We'll go through it. ARP equals RR minus 1 over RR. Well, that makes sense because you're just trying to find the percentage of something, a percent change. So how do you find a percent change? Let's go through it slow. Let's go through the tables. Here we go. What is the table going to show? Okay, well, what do we want? What's our reality? Well, the reality is if they had PTSD or not. Okay, and what's the test? Well, the test is asthma exacerbation. Okay, positive or negative. So they're trying to trick us again, of course. All right, so let's go. If they had PTSD and they had the asthma exacerbation, we're going to put 80 up here. PTSD with no asthma exacerbation, right? Going to put 80 down here. Not bad. Now, if you have no PTSD with an asthma exacerbation, okay, 50. No PTSD with no asthma exacerbation, 150. Okay, so now what do we got to find? Well, we got to find the relative risk first. They've given us all these numbers. I'm not I'm not worrying about them. It could be right. I'm doing it on my own because I like my own method better. Okay, relative risk, right? Equals 1 over 1 plus another number. All right, so we're going to go, what are we looking for? We have to read left to right, right? And that equates to top to bottom, okay? What proportion of asthma hospitalizations in patients with PTSD could be attributed to PTSD? Wow. Why would they even tell us that then? Okay, so what does this even mean? Well, we have to figure that out. Relative risk is going to be, they give us RR. Do we have to do this whole entire calculation? Not really. If they give us RR, we just plug it into the equation. We could do it. And I said I like to do it, but when you start getting all into the woods of stuff or into the weeds and you're like, I don't know where to go from here, just settle down, break it up, and be like, okay, I could do this. It's confusing me a little bit. I'm not going to do this. I'm just going to do RR minus 1 over RR. So they gave me the numbers 2 minus 1, which is in the formula, over 2. So it's going to be 1 over 2, which is not too bad. It's going to be 0.5. Is 0.5 going to be our answer? Well, we need to find the percent, so you always times it by 100. So it's just going to be 50%. So our answer is, I'm sorry. So it's 2 minus 1 over 2 is 1 over 2, right? This equals 0.5. So this is going to be our answer. 0.5. Don't go too crazy. Don't do more than you have to. I know sometimes I like to do that too, but I don't know. I didn't make this test up. They did. If we wanted to do it, if we wanted to do the chart and we wanted to avoid their numbers, what would we do? Okay, we would go 80 over 80 plus 50 over 80 over 80 plus 150, right? And you would get 80 over 130 over 80 over 230. Okay, well, this is not the math I'm doing in my head. I'm just going to do 80 over 130. I'm going to get 0.61. Interesting. I'm going to do 80 over 230. I'm going to get 0.3. And then I'm going to do 0.61 over 0.3. And I'm going to end up with 2. Okay, so we have our number 2. Same way. Same exact number that they gave us, right? RR equals 2. And now if we have 2, we just put it back into our equation, the ARP one. ARP equals 2 minus 1 over 2 equals 1 over 2 equals 0.5. Not too shabby. All right, last one. A group of researchers studying the relationship between schizophrenia and unprovoked seizures identified 36 patients who have been rehospitalized for unprovoked seizures following discharge from an inpatient psychiatric unit, and 105 recently discharged from the same unit who did not experience unprovoked seizures. The results of the study show what? Okay, I'm not going too deep into it. I'm just going to read what they want me to find out. Based on the information, which of the following is the most appropriate measure of association between history of schizophrenia and unprovoked seizures? Wow. Okay, so what do you think you do? Well, we can make a chart first if we're confused. So we make a chart. Make our box, right? And we're going to say reality, unprovoked. Okay, this is our test. So it's positive, negative, positive, negative. Okay. Schizophrenia is our reality. So if you have schizophrenia and you have an unprovoked seizure, you go right here. If you have schizophrenia and you don't have a seizure, it's right here. No schizophrenia, unprovoked seizure. No schizophrenia, no seizure. All right, well, we have our chart made. Well, does this help us? Not really. What could we read? Let's reread it. The relationship between schizophrenia and unprovoked seizure. Oh, what did we miss? The relationship. So we know it is a what type of study? Well, it's going to be a retrospective study, right? Why is this retrospective? Well, because it's in the past, so it's a case control. Well, if it's case control, it's an odds ratio. Okay, so we know all this, so we just have to do one number over another number. It's basically how we're going to get our answer. Okay, so what are we going to do? Well, we have to do schizophrenia and unprovoked seizures. All right. How can we do this? What are we testing for? So we're going to go 20 over 16 over 35 over 70. Looks weird, but let's just do it on the calculator just to be safe. 20 over 16. It's going to give us 1.25. Well, this is probably not, doesn't look good, but 35 over 70 we know is 0.5. Okay, now we could do 1.25 over what? 1.25 over 0.5. Where did my calculator go? 1.25 over 0.5. And we end up with 2.5. And that's going to be our answer right here. And that's, I think we covered all of them. We did this one before. Yeah. So, yeah, I hope it helped.